Give it a second to get started. Okay, we're live. And from Singapore, we have Nilesh. Thanks for joining us today.
My pleasure.
I have very little ceremony, so take it away.
Okay, let me start sharing my screen and let me know if you can see it. Can you see my presentation screen?
Yeah, scaling.NET Core.
Okay, so hi everybody, thanks for joining this session. It's pretty early for me here in Singapore. It's just about 7:30. I guess it's 7:30 your time. So for me, it's like the beginning of the day. And I'm quite excited to talk about scaling .NET Core containers with event-driven workloads. My name is Nilesh Gule, and I work as a big data and cloud solutions architect at one of the leading insurance company here in Singapore. A bit about myself, who am I? So as I said, my name is Nilesh. I have a website where I blog my learnings. It's named Hands-on Architect, just to stress that it's hands-on and not handsome. Once I was presenting at one of the meetup and somebody introduced me saying my blog is Handsome Architect. It's not handsome, it's hands-on. And then I've mentioned some of the social media links where I blog or my Twitter handle, my LinkedIn profile in case you want to connect with me. Apart from that, I'm also a big fan of game of cricket. So if you have interacted with the Indian people in the past, you know that most of the Indians, we love cricket. So I'm not an exception to that. I'm also a co-organizer of Azure Singapore user group, and we hold many of the meetups regularly. Since we are homebound due to this COVID pandemic, in the last few months, I've also managed to upskill myself and take up some of the certifications exams, and I'm also a certified Azure Solutions Architect. And along the way, I've cleared things like DevOps and data platform certificates as well. A bit about my background. I come from India. I was born and brought up in this small place or small state called Goa. If you've heard about Goa, Goa is very famous, at least in Southeast Asia, or when it comes to tourism in India. Goa was one of the Portuguese colony, and it was not ruled by British. So if you ever happen to be in Goa or see places around Goa, you will find a distinct architecture and things which are quite different from the rest of India. We have a lot of Portuguese influence in the way the Goan culture is shaped up. So here I put up some nice photographs of the temples, churches, and the beaches, which is the most famous part of Goa. So if you ever happen to watch any Bollywood movie, you would see that Goa is shown as one of the most happening place within India. And personally, I like to call it like the Phuket of India. And that's where I come from. Now, coming back to today's session, the agenda for today is I will give a quick overview of the .NET Core application that we are going to use as part of this session in terms of scaling the .NET containers. We will then build the Docker images. We will containerize this application. We will put it inside a Docker container. We will see what steps are required to take your .NET application and convert it into a container image. Then we will talk a bit about container registries. Then we go on to deploying this application onto Kubernetes, which is the container orchestration tool. And finally, we will look at how we can scale this using a framework or a project called as Kida. So let's look at the application that we'll be using. This particular application is a very simple one, which uses a producer and consumer kind of components, and it uses Rabbitmq as the messaging layer. So if you look at this diagram, I have a .NET Core API, which is producing a configurable number of messages. We can produce 1,000, 5,000, or whatever is the number. These messages would get populated into a Rabbitmq. And then we have a .NET exe, .NET Core exe, which consumes those messages. And those will be the consumers of that Rabbitmq message. And along the way, we will put all these components into Docker. So everything runs as Docker containers. And we deploy this onto Azure Kubernetes Service, which is a managed Kubernetes offering from Microsoft Azure. So all this code that I'm showing is available on my GitHub repo. It's named PD Tech Fest. This was one of the event in Manila where I built this demo, and I've been using this for almost more than a year now. So a quick summary of what we'll be using: Rabbitmq as a messaging layer, producer with configurable number of messages, consumer which consumes those messages in a batch, and then in order to simulate a slightly long running process, I am also introducing an artificial delay in the way the messages are consumed. So we'll have like a 2-second delay between every message when one message gets picks up and the other one starts. So this is just to simulate that we have a long running process. So let's get started. I think that's more of the slides. I will dive straight away into the demo, and we can see how to go around doing this. So let me start by showing you a bit of code that I'll be using. Are you able to see my Visual Studio Code screen here?
Yeah.
OK. So this is the repository which I have. Let me start by showing you the data model. So this particular application, think of it like a Tech Talks managing application or an event management application. And I have a small data model which is able to store Tech Talks information. So we have ID, we have a Tech Talk name, a category, and then category can be of different types. We can have a meetup, we can have a free event, we can have a paid event. And then there is level, like it's a very basic level, intermediate level. You have the expert level, so like 100, 200, 300, 400 kind of level of sessions. And this model gets reused between the producer and the consumer. So let's look at the producer code. This is a classic .NET Core Web API. So I have a small interface here, which is trying to abstract that part of communicating with the Rabbitmq. So this interface has just one method, which is send messages, and it takes a list of Tech Talks. And the implementation of that is, so let me just, okay. We have a Rabbitmq named hello, or queue inside Rabbitmq named hello. And we take some environment variables like what is the host name, username, password to connect to this particular instance of Rabbitmq. And the send messages, it takes this collection of Tech Talks, and we go through the process of creating a connection factory, connecting to the Rabbitmq using various properties, like whether you want to have a durable queue, whether you want to delete the message automatically. And using all this configuration, we go ahead and create those messages. We serialize the incoming messages into a JSON object, and we put that serialized message onto Rabbitmq as a publish message, as individual message body. And the next thing we do is the Web API. So that is a controller. So this is what accepts the request or which generates the messages. So this would be exposed as a Web API. The controller takes the event publisher, the message queue as a dependency, and we have a method which is called as generate Tech Talks, which takes a parameter of number of messages which needs to be generated. And I'm using a library here which is called as bogus. So if you are doing, let's say, unit testing, I would recommend trying to use this bogus library. It allows us to create fake data. So I can create things like category names. So I want to have a meetup, free conference, paid conference, hackathon, or event tribe. Then I can have this list of descriptions, like is it a community event? Is it a paid event? Then the levels, which I talked about earlier. And then Faker can create, based on certain number of rules, all these dummy objects. So here I have created rules for each of the properties of my Tech Talk. And I've said things like I want to randomly create a number between 1 and 1000 when it comes to the ID. When the Tech Talk name is assigned, pick a Laurel Ipsum word and randomly pick one word and assign it for the Tech Talk name. And same thing for the rest of the properties like category ID and category. And once I have all that configuration done, I can generate as many number of messages I want. So I will have those many number of messages generated, and then I send it to my message queue using this send message method. Then on the consumer side, it's just the reverse of this. So I have .NET exe, and in terms of the interface, I am trying to again abstract that communication with the Rabbitmq, and I have a single message on the interface, which is consume message. And if I look at the implementation of this, this is consuming the message which was created from the producer. So same way, we have the reference to the queue, which we want to connect to. We have the three properties for connecting to the hostname, username, password, and one additional environment property we have here is the batch size. So I can configure how many messages I want to pick in a batch. So rest of the part is same. It creates this connection factory. It connects to that particular queue, and then it tries to process the message. So I have an event handler here, which deserializes that JSON message, the body of the message. There is a artificial delay of that 2 seconds, which I talked about. And then we go and log this into the standard console log, saying what was the information that we received, the ID, name, category, and the level. So it's a pretty standard .NET Core application. So let's see how we can go ahead and build this. So I'll be using the .NET API or .NET command line to build this information or this application. I'm using Windows Terminal. So if you have heard of this, this is the new terminal which is released by Microsoft recently, and it gives a very nice shell emulator. We can have different types of shells within the same terminal. So we can connect to PowerShell command prompt if we have Ubuntu, Windows subsystem for Linux, and we can also connect to things like Azure Cloud Shell. So here, let me go into the project. So we have the tech talks model, the consumer and the producer here, and the solution file. And I can use .NET build to build my project. So this will go through the process of restoring all my dependencies, and the build is successful. Now, if I want to test this locally, I can test it. But in the interest of the time, I would like to jump a step ahead. And I hope you trust me to say that I have tested this locally. And we will see how we can go ahead and containerize this, how we can put this application into a Docker container. So for that purpose, we have what is called as a Docker file. So container, if you don't know, is a concept which allows us to package our application with all its dependencies, and it allows us to create it as a self-contained unit. So I'm going to containerize this particular these two applications or these two components of my application. And this is done using something called as a Docker file. This is the convention when we start with Docker to declaratively say, how do we want to build our application? So because of the IntelliSense or the code covering features, the highlighting, syntax highlighting, I'm using a Docker file here, but the actual project is slightly different. But the way we start is we start from a base image. So this is where I want to start my application from. And these base images are provided by all the vendors. So if you're working on Java, Java will have its own base image. If you're working with Microsoft, Microsoft will provide a base image for different kinds of applications. So I'm starting my base. What this base image has is all the components that I require for my application. So I'm basing my base image on ASP.NET Core build, and I'm using what is called as a multi-stage build. So I can define this file Docker build process into multiple stages. So the first stage I want to do is I want to build my application using the container features. So I'm creating a stage here called as build environment. And inside my image, which is based on this ASP.NET Core build, I'm creating a working directory and naming it as app. And then I copy the TechTalks consumer and TechTalks model, the contents of these two folders into that image. Then I also copy the NuGet config file and I change my working directory into TechTalks consumer. And then I do a .NET restore. So this is like normal .NET restore that we run on our own command prompt. We are doing this inside the container now. Then we run a copy command and we do a .NET publish. Now the publishing part is to make sure that we are not releasing everything that is done as part of the build process. We don't really need all the artifacts from the build. So the publish is done using the release configuration. And we specify where the output of our publish should go. And we are saying do not restore again because we already did a restore here. This is to just optimize the build process. Once the publishing is done, we have the artifact for our TechTalks consumer ready. Now we are changing the base image from earlier we were using the ASP.NET Core build here. Now we are changing it to ASP.NET Core. So the difference between these two base images is that the first one contains all the build tools. But when we actually deploy the application, we don't really need all the build tools. When we go to production, we need to keep our image size and the contents of our artifact as small as possible. So we are changing to a version of the image which is much smaller. And now from our build stage, we copy the output of that release. And finally, we say when the container instance is created, when I deploy this container onto its target execution environment, what is the entry point? What is the starting point or the starting command that I want to execute? So I want to execute this DLL, which is TechTalks consumer. So that's more of the process of defining what are the steps, how I want to containerize my application. In this project, what I have done.
I have a question then, Nilesh. So
yeah.
will is this Docker file, can that be created by a tool, or is this something you really put in manually?
This can be created by a tool. So Visual Studio, if you are using, has a very good support inside Visual Studio for generating this kind of file. So we can just say, click on our project, the .NET solution, right click and say generate Docker file. And it will do this for you. I personally like to do this by hand because it gives me a lot more control, because when we use scaffolding, sometimes it puts steps which might not really be required for us. So my personal opinion is that if we know how to do it by hand, it's much better compared to using an auto generation tool.
Yeah, got it.
OK, so I've used a slightly different approach here. This is the same for the producer as well. So the only thing that will change between the producer and consumer is the project name and the final DLL, the entry point that I call. So what I've done is at the level of my source directory, I have created the Docker files. The reason for that is instead of creating or building these images individually, I like to automate stuff and I want to improve the productivity as a developer. So what I did is I created these Docker files outside, and since the Docker file name is different here, it's not the standard Docker file. I don't get the color coding and the support for IntelliSense. So this is exactly the same, but what I've done here is I've used a different image, which is .NET 3.1, the latest version of .NET Core. And the build stage, I'm using this version of the image. This is what I'm using on day-to-day basis. So the rest of the stuff remains the same in terms of restore, the publish, and the runtime version of the image is again slightly different. It's called as the Buster Slim. And I'm also making sure that I'm not running this container as a root user, a non-root user, and this is a slight change I have done. The reason I did this is, as I said, I want to build multiple images together. And this is where I use a concept called Docker Compose, or another feature of Docker, which is called as Docker Compose, which allows me to define all the services that I need for my application in one single file. So I start with saying what are the services I need. So I have a service called TechTalks Producer. This is just a logical name. And then I have the image. So image is required for what is called as the container registry. So once we build the image, a Docker image, we need to publish it somewhere. So it's like if we have used NuGet packages, or if we come from Java world, we have used Maven packages. So it is like we created a package and we need to host it somewhere or publish it somewhere. So we use a concept of container registries here. So it's artifact storing registry, or you can think of it as the artifact registry for Docker container images. That is what is the container registry. There is the public Docker hub where we can publish our images, or we can have the private images itself, a private container registry for our organization. If you are using cloud, every cloud provider also offers a Docker compatible container registry. Like Azure, it has Azure Container Registry as one of the offering. So I will be using Azure Container Registry here. But if you want, you can publish this image onto the public Docker Hub registry as well. And the way we do that is we specify first thing, which is the container registry where we want to store our image. So in this case, I have created an instance of Azure Container Registry in my Azure subscription, and I give the fully qualified name of that container registry. Next is the repository. So repository is you can have multiple images, container instances in your repository. So what is the name that you want to give for your repository? It's like on GitHub, we have multiple repositories. So you can simulate, or you can think of that like a GitHub repository. And then we have the actual image name. So in this case, I want to name my image as TechTalks Producer. And finally, I can tag it. So it's like a version. If I use the concept of versioning in software, like when we do a release, we tag our release with a version. This is like that version number to identify what is this image version is. So I can have same image, but with multiple versions in my container registry. And then I define the build step. So when I call build, what should happen? So I need to provide a context. In my case, the context is the SRC folder, and the file it should look is the Docker file TechTalks Producer. So this file has that description, or in a declarative manner, I'm saying how I want to build my image, and Docker Compose will take that build definition or the steps, and it will go ahead and build my image, and it will tag it. Same thing for the consumer. So let's quickly go on to the command prompt and build this. So I'm in my master here, and I have this Docker Compose build file here, the same one which I'm showing in the Visual Studio Code. So let's use this and build our Docker images. So before I build, let me show you what images I have by running Docker images command. So previously I have built this about 5 days ago, and you can see that the Rabbitmq KDA 3.0 version of the TechTalks Producer and consumer is available here. I also have the base images, which I'm referring, the SDK 3.1 Buster, as well as the older SDK, which I was using before 3.0. So this is already available on my machine. If I did not have it, when I run the Docker Compose command, I can specify which file I want to refer. If I'm using the standard convention of Docker file, then I don't need to specify the Docker file name here. I can just say Docker Compose build, but since I've customized the name of the file, I have to provide the file name. And the command I want to run here is build. So when I fire the build command, it will go and look at that definition, what I showed just now. It will look at those services, the producer, consumer, and it will go through the steps mentioned in those Docker files, and it will build my image. So you can see that it's starting. There are 12 different steps as part of this process. It looks at that base image, which I've specified as SDK 3.1 in the build phase. And then whatever steps I mentioned, like creating the working folder, working directory, then copying these project folders into that, doing the restore, and then finally creating this non-root user and the entry point. So now I have the TechTalks producer created, and it's also tagged. So you can see here successfully tagged this as whatever tag I provided in my Docker Compose file. And it's doing the same thing for the consumer now. While this is building, let me go and show you what I have in the container registry. So I'm in my Azure portal, and I have already created an instance of Azure Container Registry with the name ngACR Registry. If I go into the repositories here, you can see that I have the two images, the consumer and producer. Just zoom this in, okay. And if I go into the consumer, I have the two tags, 2.1 and 3.0. So I've published these images. I think the last update was a couple of days back. Okay, so we have these images built locally on my system now. If I do the Docker images again, we can see that this is built just now. There is some problem by, I don't know, it's showing this is as 2 hours ago. But you saw that previously this was not there. This is some timing issue or the sync issue with my clock of the system. But this has been rebuilt, and we can see that these two are now available. Now I want to push this into the container registry. So this is built only on my system. This is currently available locally with me. If I want to go ahead and deploy this into the container registry, I can use the same Docker Compose command, but instead of build, I can say push. So again, the advantage or the productivity benefit I get by using Docker Compose is if I have, let's say, 10 different services in my application, I don't have to push each and every image. I can use that whole Compose file, the definition in that, and in one shot, I can push all the images. I'm getting a authorization or authentication error here because I'm not logged in into the container registry. So I will quickly log in into the container registry.
I have a question. If when you do the push, will it take what you just built, or will it rebuild it?
No, it will not rebuild it. It will take what is built. And
Okay.
the good part about
Push.
Docker is it's quite intelligent. So you will see it here now that it has the knowledge of what is already available or what is already pushed into the container registry. And it will only push changes if there are any. So you can see here that it can identify that all these layers which are built into my container image, they already exist in the remote repository. So it's not pushing anything new. So let's say I made a change in my code and that added a layer, only that particular layer will be pushed onto the container registry. So in that sense, Docker is intelligent enough to manage the deltas.
Cool.
And
thanks.
The important thing here is because this involves network traffic, we should always try to reduce the size of our images because every time we build an image, every time we push it to a container registry and we want to deploy, that whole image definition has to be pulled down onto your deployment environment. So it's always a better practice to make sure that we are not adding too much layers into our Docker images, and we try to keep them as small as possible, so that our deployment process gets faster. So now I have the image built. I have the image pushed also to my container registry. Now let's look at how do we deploy this. In terms of deployment, this is where we use Kubernetes. Kubernetes is the orchestration tool. So I like to think of Kubernetes as in the analogy of, let's say, planes and the airport. So if we think of Docker, I would say Docker is like you have multiple small components. So these are like planes flying in the air, and then you need somebody to control those planes. Let's say you want to have multiple instances, you want to scale your operations, you want to have number of instances of your images, how many can run at a time, and what happens if one image goes, there is some problem, and you have to replace that image. So for that kind of operations, you need somebody who can do this kind of operations, and that is where Kubernetes comes into the picture. So think of Kubernetes as airport authority who can tell, okay, who can land on a particular airstrip, who can take off, at what time it can land. It orchestrates all these things. Let's assume something is running and something goes bad. So your traffic was a plane landed and you were supposed to get your baggage on, let's say, belt number 1, but that belt went down. Now it has to be shifted to belt number 4, and all the passengers need to be informed that, okay, you are not supposed to collect your baggage from belt number 1. Now you have to redirect to belt number 4. So these kind of things which happen in real life, we can simulate, or we can handle those kind of things using orchestration tool, and Kubernetes is one of the most popular one. It allows us things like having scalability. We can have multiple instances of our Docker container images running. If it has a self-healing capabilities as well. So let's say we said we need 4 instances of our application running, and something went wrong and one of the instance went down. Kubernetes will automatically detect that one instance has gone down. It has this desired state configuration capability, and it will automatically provision a new instance of that service which went down, and it will schedule it. So let me show you quickly how we can take this image now that we built, these 2 images, and we can deploy it using Kubernetes. So for Kubernetes, I use the concept of what is called as a manifest file. So Kubernetes allows us in a very declarative way to describe how we want to deploy things. So I have, let's look at the producer first. And the different aspects of the producer configuration. So I use a API provided by Kubernetes, and it has multiple versions. So I'm using version 1 of the apps API of Kubernetes. Kubernetes provides different kinds of objects, and deployment is one of them. So deployment is a very high level construct in Kubernetes, which allows us to specify. So metadata is just a normal metadata about this deployment. I am naming this deployment as Rabbitmq deployment. I can define some labels saying this is Rabbitmq producer. And then in terms of specification, this is where I can specify how I want my deployment to happen. And I'm saying I need 2 replicas for my producer. The selector is a Rabbitmq producer. This is used in the next construct that I'm going to explain, which is the service. But for now, let's skip the selector part. And then we have the template. Template again has a metadata. But the interesting part is this, the specification for container. And we can define multiple containers as part of the deployment, but as a best practice again, we should have 1 container per deployment. That's more of a standard approach which people follow. So in the containers, I am creating a container named TechTalks producer. The image based on which this producer has to be created is that image which I published. So again, I am referring it the same way, giving the fully qualified name of my registry, then the repository, then the image name, and then finally the tag of the image that I want to refer. And I also specify what are the environment variables. So this is where I can customize my environment variables for different environments. So let's say I have a different host name in my development environment. I have a different host name in my UAT or staging environment, and I have a different host name for Rabbitmq in my production environment. I can customize that. I can change the environment variable names here. So I specify all the environment variables that are required for running this producer. Again, since it's a demo, I'm putting these as clear text, the username and password. Please don't do this in production. You can use things like Key Vault to store this and retrieve this from Key Vault in a secure way. And then I have the port. So port mapping is a feature available in Docker as well as in Kubernetes, where I can say my container runs on 8080 port or 8080. Do I want to expose it using the same port number? Let's say there is another application which is already running on 8080. I can change the port number here saying the container inside runs on 8080, but when I expose this as a service, or when I deploy it as a service, I want to run this on a different port. That's also possible. And then I specify the policy to say I want to pull the image every time an instance of this container is created onto a particular host. If I want, I can also say only if the newer version is available. So that's another optimization which can be done. But in this case, I have configured it to pull the image every time I want to deploy this particular image. And then I can also specify other properties like restart. What should happen if for some reason this image, which is already deployed onto a Kubernetes cluster, gets killed or gets terminated? Do we want to restart it always? And then we have the termination grace period defined as well. So if we give a command to terminate this particular instance of the producer, we don't want it to terminate immediately. Maybe there is some cleanup which I want to do, like if I want to close the connections to Rabbitmq or any database that I might be referring to, I can define a grace period in seconds, after which this particular instance of the container would be terminated. So this is for the web API, the producer. Now I am saying here that I need two instances. If you see replicas, I've specified two replicas of this particular producer to run in my Kubernetes setup. How do I connect to this? If there are two instances running, I should have a way of connecting to either of those two producers. That is where the load balancing of Kubernetes comes into the picture. And we have another construct within the API provided by Kubernetes, which is of the kind of service. And this is the one which is doing load balancing. So it again has a similar structure in terms of metadata. I specify that this is named as Rabbitmq producer service. And the type of this service is a load balancer. And this is load balancing on port 8080. And what is it referring to? This is referring to my producer. So this is where that selector, which I was showing earlier, comes into the picture. So if you look at my deployment, I have a label here which says the run as Rabbitmq producer. So that is how my service knows which instance of the producer I need to load balance. So if we work on more of the advanced scenarios, like where we are doing, let's say, multiple versions of the same service deployed in production, like there is this concept of canary deployment in modern deployments with microservices, or you have AB kind of blue-green deployments, then I can have a different label here for different services. And then there could be a different load balancer, which is picking a different selector. So this is addressing that need where there are multiple instances of the service and you're trying to connect or you're trying to load balance to a specific instance of that service. Mm-hmm. So that's the producer part. On the consumer side, I have similar configuration, but this is not an web API. This is a .NET EXE, if you remember from the earlier code that I showed. So the configuration for EXE is similar in terms of the object that I use. I'm still going to use the higher level construct of deployment. I still need to provide this generic metadata, like what is the name of my deployment, what label do I want to have. And in terms of specification, I'm saying I need one instance, one replica of this. And the template that I provide here is I'm using the Rabbitmq consumer part here, not the producer, and the environment variables. So I don't need to expose these using the port and the other things because this runs as a EXE. So the configuration here is slightly different as compared to a web API. OK, so once we have this, how do we deploy it? So for the deployment purpose, what I've done is I've gone ahead and created a Azure Kubernetes service AKS cluster beforehand. And I like to automate most of the stuff. So I have created various PowerShell scripts here. So let me quickly walk you through what I have done for the cluster creation. And then I will show you the cluster as well. So I have this script which takes multiple parameters like what is the subscription name, what is the resource name, what is the resource group location where I want to create. I've set these defaults, but since it's a parameterized one, you can always change this when you call the script. You can override these values. The cluster name I have given here is AKSMQ cluster, and then the worker node count. So I've specified the worker nodes as 3. I need 3 nodes of particular size. I didn't specify the size here. So it will take the default size of the VMs, and it will also use the container registry. So the container registry is the one that I showed in the portal. NGACR registry is the one I'm trying to use for my Kubernetes deployment here. So we start by going through the subscription. We log into our subscription. Then we check if the resource group exists. If it doesn't exist, so this script is idempotent. You can run it multiple times. It will check what is existing, and if things exist in our environment, it won't do anything. So only if the resource group doesn't exist, it goes and creates the resource group with the resource group name and the location that I provided. And then we look at the Azure Kubernetes service command itself to see if the Kubernetes is already available, the cluster is already created. If the cluster exists, then we don't do anything. If it doesn't exist, it will go fire this AKS create command with all these parameters, the resource name, the cluster name, the node count that we specified, and we are using managed identity. So this is the security concept where when we create the cluster, we also create Azure Active Directory identity and associate that with our Kubernetes cluster. The way this helps us is to securely connect to our container registry. So when I say attach the container registry, the NGACR registry to this Kubernetes cluster, the managed identity which is created as part of this cluster creation process will have the permission to pull images from this container registry in a very secure manner. So that is for the security reasons. I am creating a managed identity, and I am also attaching the container registry at the same time. If you have already created the Kubernetes cluster, you can still attach the container registry later on. You can run a different command to say update the cluster and attach this container registry to that. And then we get the credentials for this particular cluster. So I have, in the interest of time, gone ahead and already created this cluster. So let me show you the configuration of this cluster. So I'm running kubectl, or the command line tool of Kubernetes, which is called as kubectl or kubectl. And I run a command to say, give me all the context that I have on my PC. So I have currently 4 different clusters which are up and running, but the one which is currently set, the context currently set to is this cluster, which is AKSMQ cluster in the Demo Florida meetup resource group. That's where our current configuration is pointing to. So let's go and look at the node. I can fire the kubectl get nodes command to get information about the 3 nodes that I provisioned. So you can see here that this was created about 8 hours ago. I created this yesterday night, and these are the 3 nodes which are created. So there is a node with VMSS all zeros, then 01 and 02. I can also visualize the state of this Kubernetes cluster using open source tool or an add-on called as Octant. So Octant gives you a very good user interface to see what's happening in your cluster. So I'm now on the same cluster, AKSMQ cluster. And if I go down into the nodes section, we can see the same 3 nodes here. And we can see what version of Kubernetes is installed on those nodes. And we have additional information about what is the size of the node. It's running the Linux operating system. What is the IP? It also has the capacity. So in terms of memory, this has 7 GB of memory, or it's allocated, created with 8 GB of initial memory, and then it can schedule 110 pods. So a pod is equivalent to a container. The smallest unit of execution on Kubernetes is called a pod, and it's more or less equivalent to one instance of the container. So that is my Kubernetes cluster with 3 nodes. Now I want to deploy my application onto this. So let's go and deploy the application. Again, in terms of time and the productivity part, instead of running the commands on the command line, what I do normally is to put those as PowerShell scripts. So in order to run my application, I have a dependency on Rabbitmq, if you remember. So for the Rabbitmq installation, I have a small script here, which is using a concept called Helm in Kubernetes. So Helm is like a package manager specifically for Kubernetes application. If we have to set up a Rabbitmq cluster, it has so many prerequisites. So instead of me going and configuring each and every prerequisite, what I can do is I can use Helm. It's like a pre-built package. It contains everything that is required for me to deploy a RabbitMQ cluster on my Kubernetes environment. So I can refer to this using what is called as a chart. So chart is a definition or the artifact for Helm, and I'm referring to one of the Bitnami charts, which is one of the leading provider of RabbitMQ cluster or RabbitMQ installation on Kubernetes. I do a Helm update repo, so it is like I'm referring to this. I just want to get the latest version of the chart, and then I install RabbitMQ onto my cluster. So let's go back here and see if we have the RabbitMQ. CTL. Get pods will tell us what pods are running. So you can see here right now that there are no resources found in the default namespace, and we don't have any pod scheduled or any pod running at the moment. So let me go and install this RabbitMQ onto my environment, onto this cluster. So for deploying RabbitMQ, I will be using this deploy RabbitMQ PowerShell script.
Nilesh, you might mention in Kubernetes the nodes, the pods, what the relationship is.
Yeah, sure. So when we create a Kubernetes cluster, we have the different nodes. We can define the size of the cluster. It's not just one virtual machine where Kubernetes is running. We can have multiple nodes, and then we deploy the application onto this node. But the way we deploy that is in a very declarative manner. So that is what I try to do here in my manifest files. So if we look at the producer or the consumer manifest, here we are just saying how does our application has to get deployed onto Kubernetes. We never specify which node it has to be deployed or what IP it has to be assigned to. All that is done behind the scenes for us by Kubernetes. So Kubernetes API has these different controllers and different features built into it to take this definition or this declarative settings that we provide and convert it into actual deployment. And when I say deployment, I will show you in a short while. There are various things that goes behind the deployment kind itself. When the object of kind of deployment is created, it's broken down into multiple steps, and Kubernetes API is able to do all. So I have gone ahead and deployed a RabbitMQ cluster here. So you can see that it took hardly about a few seconds to go ahead and get the latest version of the chart from that repository, Bitnami, and deploy a Kubernetes cluster. Sorry, not the Kubernetes, it's the RabbitMQ cluster. So now if I go and say kubectl get pods, we can see that it's creating an instance of RabbitMQ. It has gone ahead and it has created a running instance of, it's trying to create a running instance of the Rabbitmq here. So let's try once again and see if it's ready. Still trying. Okay, let's give it a few seconds to provision this. Now we deployed a third-party application or Kubernetes cluster using Rabbitmq cluster using Helm. How do we deploy our own application? To deploy our own application, I will use these manifest files and I will use a combination of the kubectl commands. So kubectl allows us to run these what is called as the create or the apply command. So the difference between create and apply is if the object doesn't exist, it will create it. Apply works more in an idempotent way. It will see if the object exists, but if there is any change in the configuration, it will go ahead and apply those changes on top of the existing object. If there is no change, then apply doesn't do anything. So what I'm trying to do here is I take that consumer deployment file and I want to apply that onto my Kubernetes cluster. Same way, when it comes to the producer, I use the apply command recursively and I deploy the producer. The recursive one I'm doing because if you look at my producer has got two files, the deployment file for the producer itself and then to expose it as a service. So in order to deploy both of these, I'm using the recursive flag here. So let me go ahead and deploy this. Let's try once again if the Rabbitmq is running. Usually it doesn't take so long. Within 2 minutes, it's ready.
It's a demo, that's why.
Yeah. Okay, while this is getting created, let me go and deploy our application. It doesn't harm to deploy the application. So deploy TechTalks. This is the script I'm going to use. So it will go deploy the TechTalks consumer, TechTalks producer. And now if we run the same get pods command, we should see the pods for our consumer and the producer being created. So you can see here that it got the application up and running within 20 seconds. The producer was able to run within 20 seconds. It deployed or it pulled the image onto this cluster and it got it up and running. That's how fast we can get the applications to run on Kubernetes because of the way that container image contains all the, it's self-contained. It has everything that is required to run the application. So we can see here that the consumer is running, but unfortunately for some reason, the Rabbitmq is still not running. So let me try one thing here. Okay. Let me uninstall the Rabbitmq and then go and deploy it again. So hopefully it should work this time. Okay, it's creating. We can also run a watch here to see if anything is changing.
Is the consumer crashing because the queue isn't running?
Yes. Because it's referring to the Rabbitmq, and since Rabbitmq is not running, the consumer is crashing. This is another beauty of Kubernetes. It will keep trying. So you can see here that it has already restarted 4 times. So it has tried on its own because of its self-healing nature, the way Kubernetes works. It has killed the container which was crashing, and it has tried to rerun that.
David,
there is a way to define.
Go ahead.
No, I'm asking. There is a way to define dependency, correct? So in other words, your container will not even start if you don't have Rabbitmq running.
Yes. There is something called as init containers. So we can define which containers has to be started before your actual application container can start.
What? How do we know if I'm a trader or not? Just a question.
Let's just give it 1 minute and see. So while this is still trying to get the Rabbitmq running, let me show you some of the features of the other pods. So we can see here, let me zoom this in a little bit. So in the pods which are already created, I have the 2 pods for the producer and the 1 pod for consumer. And if we look where it got scheduled, 1 pod for the producer got scheduled on 01 node and the other one got scheduled on 02 node. So this is another benefit of Kubernetes. We just gave it a declarative way saying I need 2 instances. I did not specify that it needs to go and schedule itself on the 01 node or 02 node. Kubernetes automatically decided that these 2 nodes are available. It has enough resources to schedule these pods, and it went ahead and scheduled it on these 2 different nodes. And then the 1 instance of consumer got scheduled on 01 node. Whereas when it came to the Rabbitmq, it went and scheduled it on 02. And we can see here now that the Rabbitmq is in ready state. So Rabbitmq has up and running in about 3 minutes. Now we should see that the consumer is fine. The next instance, when it tries, the consumer also should be running. So let me just switch this here quickly. It should pick up that this is running fine. One more, please. Come on.
Yeah.
Okay, let me try the. Okay, fine. There we have it. So now we can see that the consumer is also up and running on the 6th instance. When it tried the 6th time, it managed to find a running instance of Rabbitmq. Now let's go and generate the workload. So for generating the workload, I need the public IP of that API, which I have exposed using the service. So to get that, in the Octant, I have the services tab, and I can pick up this public IP of my producer service, and I will use Postman here to generate the workload. So I'll just change the IP, and let's say we need 3000 messages to be generated. So we got the response as 200, which means now we have 3000 messages populated. If we go into the Rabbitmq UI, we should see the messages populated here. Okay, let me again regenerate that. So for the Rabbitmq, what I'm doing is I'm doing a port forwarding. So port forwarding is another concept in Kubernetes where I can say there is a service running Rabbitmq service, which is exposing port 15672. and I want to expose that, or I want to tunnel to that from my local system. So I'm forwarding from my local computer. I'm doing a port mapping basically. And now I will be able to connect to that using localhost 15672. And we can see that there was a spike here. Those 3000 messages, they got pumped in, and there is one instance of consumer running. And if we look at the configuration of the consumer, okay, it is consumer deployment. In the configuration, we have given the Rabbitmq batch size as 100. So that is why it picked up 100 messages, and it's trying to process those 100 messages. So if I go back into Octant, let's go into the workload. Let's look at the consumer pod. And we look at the logs. We can see here that it's now processing those messages. And if I display the timestamp option here, you will see that every 2 seconds, 42, 44, 46, that there is a log being generated. So the messages are getting processed within that delay of 2 seconds. The other thing which I wanted to show was that of this resource viewer. So you can see here that I created a deployment type of object, or I declared I wanted to have a consumer deployment in my manifest file when I created that YAML file. But that deployment got converted or translated using the Kubernetes API into what is called as a replica set. And the replica set, we said one instance of this has to be running. So there is one replica set and there is one pod of the consumer. If I go into the pods for the producer, we should slightly have a different representation there. Sorry, resource viewer. So we can see that the same way, there is a deployment which created a replica set, and that created a pod, and this pod is exposed using service. There was, yeah, sorry, this UI is changing, but you can see on the right hand side here, just next to when I hover out, there is a service also exposed here. So this is very useful. I find the Octant UI. You can find what is actually getting deployed. Although we use higher level construct like deployments, how does it actually get translated into the different objects at the Kubernetes level? So now let's move on to the next stage. I have only one consumer running. You see in the pods, only one instance of the consumer. And if we are to consume all those 3000 messages, it will take quite a long time. This is not an ideal scenario. We want to process those messages as early as possible. So what I'm going to do is I'm going to introduce something called as KEDA. KEDA is a project, open source project, which is meant for doing event-driven processing. I will come to event-driven processing later, but let me, in the interest of time, since I have about half an hour left, go ahead and deploy KEDA first onto our cluster. So deploy KEDA is using similar concept like we deployed Rabbitmq. It uses a Helm chart to get the latest version of KEDA repository, and then it deploys all the objects required for KEDA. So now I have KEDA deployed. I need to make another slight change, which is to deploy autoscaler. And what this autoscaler is doing is it's trying to scale my deployment. So in the interest of time, I will again skip a little bit of this configuration, which is required for running the autoscaler. But what it is essentially trying to do is it's trying to connect to my Rabbitmq and look at the queue length. And I have specified that the queue length, if it is 5 or more, you should poll every 60 seconds. The default is 30 seconds, but I've made it as overridden it into 60 seconds. I want to have a maximum replica of 30. And what 30? So the replica that I want is of my consumer deployment. So I want to scale between 0 and 30 as long as there are messages to be processed. in my queue. So with this, what you will see is, let me quickly go on to the watch part here, and I will use here watch on the pods. So you can see right now that there is the consumer, one instance is running, producer, two instances are running, and Rabbitmq, only one instance is running here. Let's clear. On the downside, I want to show the deployment. So the deployment of this is there is only one deployment of consumer, and there is two deployments of the producer which are running. That is based on my initial specification that I gave. What we should see in a short while is, because we gave the time as 60 seconds. Once that polling kicks in, we should see this consumer scaling automatically, because we have still quite a few number of messages to be processed in our Rabbitmq. So if I go here, we still see that there is only one consumer running as of now, and still 2,700 messages to be processed. So I hope that we don't have a demo effect again, and the autoscaler kicks in. So let me try what are the pods we have currently. So we do have the KEDA pod running, so it should kick in. Come on.
How's Nilesh, how's the COVID pandemic there?
How is the COVID thing you're asking?
Yeah.
COVID, it's quite well managed in Singapore. So we don't have many cases in the community at the moment, and things are getting back to normal. Many of the restrictions that we had about 6 weeks back, they are being released in a phased manner. So we have things like movie halls, malls, and the common places for public opening up shortly. Although we do have to maintain social distancing, but it is improving.
Excellent.
Yeah. Oh, the scaled object was deployed, so let me just try deploying it once again. So you can see here that it is unchanged, but it did create the scaled object. Okay, let's see if this kicks in the stuff, because something got created.
This is
Yes.
There you go.
You can see, yeah. So we can see here that initially it started the consumer deployment with 4. It tried to scale from 1 to 4 because it thought that, okay, or it went from 1 to 2. 2 is not enough. So progressively it went to 4. From 4, it went to 8. And then we should also see that it goes to 16, and 16 becomes 30, because our limit or the range that we have given is 30 here.
Right. Will this scale down too?
Yes, it would also scale down. So the autoscaler of KEDA, it works on the matrix. So maybe that's a good time for me to switch back to the presentation mode and quickly show what is the architecture of KEDA. So we covered all this. How do we push to the container registry, and then how do we pull those images using that managed identity from the container registry onto our Kubernetes cluster. Now we are talking about KEDA. So the way KEDA works is it adds something on top of the existing Kubernetes cluster. So the requirement for KEDA is, the full form of KEDA itself is Kubernetes based event driven architecture or auto scaling. So it works specifically with Kubernetes only. So it reuses the objects or the constructs available in Kubernetes and extends it. So what happens is it will use a concept called as horizontal pod autoscaler, which is available in Kubernetes. And then it adds its own controller. It adds its own matrix to adapt to this horizontal pod autoscaler. And the way it does is it monitors the source of the event. In our case, the event source is Rabbitmq, and based on the number of that configuration, which I said 5 as the number of messages, the queue length, it will keep monitoring that if there are more number of messages than 5 to be processed, and it will do this calculation based on the range that we give 0 to 30. It will identify if there is a need to scale up or scale down, depending on how many messages are still to be processed. And the number of sources that it supports is, you might, since we are part of Azure, you might recognize some of these icons. In case you don't know what these icons are, the first one is for the Azure Event Hub. It also supports the Azure Service Bus, and it supports the storage queues. That's part of native Azure support. When it comes to other third-party or external messaging frameworks, it supports the commonly used or popular frameworks like Kafka, Prometheus, Rabbitmq, which we are using in this example. It also supports Redis, Lickless, and NATS. When it comes to the cloud providers, it has support for AWS CloudWatch, simple queue service in AWS, and on the GCP side, the PubSub. And it also has support for the Azure functions. So we can see that it can cater to different types of event sources. So let's go back here and now see what's happening on the Rabbitmq side. So we can see that the number of consumers is 30. So in a batch, now we have 30 into 100 messages being consumed, and we can see how many are remaining. So once all this is consumed, once the message count goes back to 0, we should see in a short while that this starts to scale down. So right now, everything is running. All the 30 instances of our consumer are up and running. But in a short span of time, we should see that it starts to scale down as well.
No, as I was saying, this is a very ambitious demo.
I've done it many times. So
Yeah.
I think this is the 8th time I'm doing this demo. So I'm like quite comfortable doing it, but this is the first time I had this issue where the scaler didn't kick in immediately. Okay, so now we don't have any more messages to be processed, and we should see that the scale down also works fine. So it will wait for that 60 seconds, the polling interval in between, and it should realize that the queue has ran out of the messages. So while we are waiting for that, now I want to extend this to the next level. So what we have done so far is we created a 3-node Kubernetes cluster. We deployed the workloads onto that 3-node cluster, and then we scaled it using KEDA. Now imagine that you want to optimize your resources. The way Kubernetes resource is charged is based on the VM size that you provision for your cluster. So if I were to keep this 3-node cluster running 24 hours, I would be paying 3 times that VM cost. But maybe the use case that I have is I don't need to keep this running all throughout. I have the need, let's say, to only have this cluster running for a short period of time. Maybe I'm running a promotion and I expect that the number of events which would be populated into my Rabbitmq is only for a short burstable period of time. In that case, I don't need to keep all these 3 nodes running. I can definitely scale the Kubernetes cluster. but it will take time to scale because the VM has to be created. All the Kubernetes services has to be installed on that VM, and that VM needs to be added to your existing running Kubernetes cluster. This can take much more than, let's say, 10-15 minutes to happen. And you might not want to wait 15 minutes because your processing needs might be that you have to respond to these events which are lying in your Rabbitmq or any other source that we looked at in the KDA supported options to happen as quickly as possible. So in that scenario, we could use the serverless capabilities of Azure. So let me quickly switch back to the presentation mode again, and let's see how we can go ahead and use the feature of Kubernetes, which is called as virtual node. So what happens in virtual node is, let's look at the first half here. So we have, let's say, a basic Kubernetes cluster or a base Kubernetes cluster with 4 virtual VMs, VM1 to 4 here. But we want to extend this using a serverless capability. That is where virtual node comes into picture. Virtual node, it allows us the same application programming interface or API as that of physical Kubernetes cluster. But instead of scheduling the workload on these VMs, what it would do is it would schedule it on the serverless Azure container instances. And the benefit that we get is if these VMs cannot handle the load, it will automatically scale that onto the serverless infrastructure. So we get that quick benefit. We have the quick turnaround. So the benefits of that is it scales very quickly. It provides the same level of abstraction. So we don't have to do or we don't have to learn anything new to use this serverless feature. And it gives us additional resources without having to manage the physical nodes. And this virtual node is supported by most of the cloud providers. AWS has its own support for virtual node. Azure has is using the Azure container instances. Alibaba Cloud, if you are using, that also has its own support, and all the others also. The downside of this is it is very heavily dependent on the provider features. Because we are using Azure container instances as the way to scale it. So whatever Azure container instances feature set is available, that is applicable to the virtual node. So some of the things like service principal, the virtual network limitation, init containers or daemon sets, these are not supported by Azure container instances, and this applies to the virtual node as well. If we want to use any of these features, we won't be able to use the virtual node. So the way virtual node works is instead of creating everything in the same Kubernetes cluster, we split the Kubernetes cluster into 2 parts. We have the base Kubernetes cluster running on a subnet or a virtual network called as the Kubernetes virtual network. And then for all the virtual node related part, we create another subnet. And we say virtual nodes will be scheduled onto this separate subnet. And that is how we scale from a physical Kubernetes cluster or virtual Kubernetes nodes, virtual machine based Kubernetes node onto the serverless Azure container instances. So let me show you this demo as well. While we see that the scale down has happened, so we can see that it got terminated within 5 minutes, and from 30 we went back to 0 because our range here was 0. We can see that minimum replicas we specified it as 0. So now for the purpose of this scaling on the virtual node, what I have done is I have created a different configuration because it requires a slightly different configuration for the Kubernetes cluster itself. So let me quickly walk you through that. When we create the Kubernetes cluster with virtual node, what do we need? So the first part is same, where we look at the subscription. We check if the subscription exists, resource group, if it exists. If it doesn't, we create, and then we start creating those 2 virtual networks. The one for the base Kubernetes cluster itself, and the other one for the virtual nodes. And then we assign some address prefix for that. And then we create a service principal. Because when we create a virtual node, we cannot use the managed identity. the earlier concept which we were using in the previous demo. We have to create a service principal and we have to assign that service principal to this virtual network so that it can schedule workloads onto a different virtual network. And then we also assign that same role as the permission to pull the images from our container registry. So that's the additional work I have to do in order to schedule the workload on the serverless infrastructure. So this goes through the various steps, and at the time of creation of the actual cluster, we have to provide these additional configurations saying I have to use a network plugin of Azure here. I have to give the CIDR address, what is the DNS address that I want to have, what is the Docker bridge address. So all these additional settings or parameters I need to pass along with what is my subnet ID for the virtual node subnet and the service principal that I want to use. So with this, I'm also enabling the monitoring on this particular cluster. So I've gone ahead and created this second cluster, which is for the virtual node. So let me switch my context here to that cluster. So the name of that cluster is AKS vNode cluster. So now I'm pointing my Kubernetes CLI to this virtual node cluster. So let me go and quickly show you how the nodes look like here. If I run the get nodes command, now you can see that, OK, let me go back to the configuration again and control home. You see that I created the worker node count as 1 because I want to optimize my number of VMs which I'm using. And I want to scale on the serverless infrastructure. So I created a cluster with only one worker node. And then I added that virtual node. So you can see that from the API point of view or from the Kubernetes point of view, it sees that this as two different nodes. And we see the physical node which is created 001, and the other one is the virtual node, and it's using the ACI Linux as the name for that. Let me go back into the octant as well and show this. So let me switch into the virtual node cluster here, and if we go into the nodes, we can see the same thing. It's the physical node or one virtual machine and one virtual node created. And in terms of the configuration of the virtual node, if you go down, you can see that it has the capacity of 4 terabytes of memory, and the number of pods that it can schedule by default is 5,000. So now how do I deploy my application onto this virtual node? Do I need to make any changes? There is a definite change in the consumer, because producer, we are not changing anything in the producer side, but on the consumer side, what we want to do is consumer is the one we want to scale on the serverless infrastructure. So the change that I am doing in the specification is the first part still remains the same in terms of which image I want to use and what is the size of the batch size. So here I have created a batch size of 50. The image pool policy also remains the same, but I have to specify image pool secret because I don't have that manage identity on the serverless infrastructure. So I created a service principal and I have created a secret in my Kubernetes cluster at the time of creation of the cluster. And I'm using that secret to connect to my container registry to pull the image. So this is one additional setting I need to specify. And then I need to specify the DNS policy. So these values, the 10.0.0.10 is what I specify in my the cluster creation configuration itself. So if I go back to that PowerShell script again, virtual node, you can see that I should find that 10.0.0 in the configuration.
Right there.
Yeah, so we use that, and then we also have to specify some additional configuration for the DNS. The main part is these last 7 or 8 lines. So this is based on what is called as the taints and tolerations in Kubernetes. So we have what is called as a node selector. So we are specifically saying that in order to schedule this workload, you need to go and look for a specific node. That node needs to have a role of an agent. It needs to have the OS as Linux, and it needs to have the type as virtual kubelet. Only if these properties are available on the node, you can then go and schedule this using the provider of Azure onto that particular virtual node. So this again we can verify if I go into the nodes, if I go into the virtual node, and if I look at the YAML part of this, you can see that it has got these labels, which has the OS as Linux, the role as agent, it has the type as virtual kubelet. So based on these labels, it tries to filter, or it tries to point the workload onto this specific node. And then we also have this taint, which is the value is Azure and the provider is the key. So we use the combination of those labels and this taint to say, I want to schedule my workload for the consumer specifically on the node which has these characteristics. So with that, let me go and show you how does this work on the actual cluster itself. So let me go back into the portal and let me show you in the container instances that currently there are no container instances running because I haven't scheduled any workload. Now I changed the Kubernetes API to point to this node. I also need to change my Rabbitmq part because I have changed the cluster now. So let me go back and just do the port forwarding again. So port forwarding is fine. So now we are pointing to the new cluster, the one with the virtual node. Let me also change this, the watch that we have. So let's watch for the nodes. Sorry, not the nodes, the pods here. kubectl get pods -watch. So I've already gone ahead and deployed the producer and the consumer, the application, KEDA, everything onto this cluster when I created it. Now let's watch for the deployment here. Get deploy. And we can see that there is no instance of the consumer running, but the 2 instances of our producer are running on this virtual node related cluster. Now let's go and generate the workload. To generate the workload, I need to get that IP again from Octant for my service. And let's go in the Postman and change this. And let's say we want to generate 2000 messages now. Okay, so successfully we have sent 2000 messages. If we go on to the Rabbitmq, we have 2000 messages ready here. And now let's look at the watch. This should kick in a short while. Yep, we can see that the consumer has started scaling, and we should also see that, sorry, if I go into the container instances, it should start showing up here. This takes a bit of time because the image has to be pulled onto the ACI infrastructure. It is not running onto our own VM on the Kubernetes cluster. So it needs to find the right instance available, but we can see that now we have the 4 instances created. So what we have done here is, instead of running this workload on our own Kubernetes cluster, we have scheduled it onto the serverless Azure container instance. And this will again scale like the other physical cluster. So you can see here that it has gone from 8 to 16, 16 to 30, and all those instances are coming up. And then we will have the same things being seen on the consumption side. So the Rabbitmq, we will see these messages going down as the number of consumers come up.
It's magic.
Yeah. So that was my demo. I can now go back into these slides. So I think we can go into the summary. What did we see during this whole about almost 90 minutes now? So we started with Docker. We created a self-contained application. We packaged our application with all its dependencies into Docker container. We created a producer and consumer as the container images. Then we used Kubernetes. We also pushed those images to our private Azure container registry. Then we went on to the Kubernetes mode where we used the orchestration feature of Kubernetes. We looked at the self-healing part as well. When the consumer was not able to find the Rabbitmq instance running, it was trying again and again. At the 6th instance, it was able to self-heal itself. We also looked at the service discovery part where we had 2 instances of our producer running, and we were still able to use the service feature of Kubernetes to load balance across those 2 instances. And we also looked at the scaling. One thing which I didn't show you because of the lack of time was instead of using KEDA, I could still do the scaling myself manually. So I can say I have this deployment which is named as my Rabbitmq producer. I want to scale it to, let's say, 10 instances. So I can say, let me show you the command at least so you can understand what I'm talking about. So I can say kubectl scale. The type of scaling I want to do is for deployment. The name of my deployment is Rabbitmq consumer deployment, and I want to scale it to 5 replicas. So this way, manually, I can go ahead and scale my deployments. That's also possible. But again, manual deployment also means you have to scale down manually. And in today's world, that's not the most optimal way. We have better tools available. And as we saw, using KEDA, which looks at your different sources of messages or different event sources, it can scale within the range that we provide. And finally, we also looked at the event-driven capabilities of the KEDA. So we were also able to scale it onto a serverless infrastructure. So that was pretty much the demo I had, or rather 3 or 4 sub demos within the presentation. What I would also like to give you in terms of references is, if you want to learn more about this, where can you go? To start with, if you don't know about Docker, there is an online resource where you can play with Docker without having to install Docker on your machine. Or let's say you are doing it at your organization office where Docker is not available. You can do play around with Docker using Play with Docker. Similar concept applies to Play with Kubernetes. You have a website where you can play around with basic features of Kubernetes. In terms of learning more about Kubernetes, there is a MS Learn path which is available. And if you like learning from these online e-learning providers like Pluralsight or Linux Academy, there are courses available on these e-learning platforms. Kubernetes is one of the most popular projects over the last 2 or 3 years. So every e-learning platform will have their more than one provider or more than one author publishing Kubernetes and Docker related courses. In terms of the reference itself or doing things on your own, I highly recommend this resource, which I personally found useful. It says 50 days from zero to hero with Kubernetes. It is created by the co-creator of Kubernetes itself, Brendan Byrne. And what I like about this is the bite-sized videos that he has created. It's like 5 or 10 minutes. He goes in a very informative way to explain how different things like deployments, the replica sets, the pods, services, the self-healing part of Kubernetes works in Kubernetes. And then there is also things like monitoring and the high availability aspects as part of advanced things, which are also covered in this very good handy resource. Then I've also given some references here for the things which I've used during the demo, like horizontal pod, autoscale, virtual kubelet, the KEDA project itself. Let me quickly go back to the KEDA website. If you want to learn more about KEDA, KEDA is available on GitHub as KEDA core, and there is also a website. So the event scalers that I showed was slightly outdated from earlier, one of my earlier presentation. But if you look at the current state of the scalers that KEDA supports, we have all this, what is listed here. And this list is growing day by day. What I also have in terms of books or ebooks, if you want to learn about building applications using Docker and Kubernetes, are these some of the books which are freely available. And this was the Kubernetes MS Learn path, which I was talking about. This is about 2.5 hours containing of 11 different modules. And you can learn very much everything about Kubernetes on this, or rather the Azure Kubernetes service. The code for this demo is available on my GitHub repository. You can have a look at this. You can rerun all of this that I showed you if you have the Azure subscription. Not just Azure, because KEDA works with any Kubernetes instance. So you can customize it to your own Kubernetes. If you're running, let's say, Kubernetes as a Minikube installation, or Docker for Kubernetes in the new versions of Docker Desktop, you can run the same thing over there. So thank you very much for having me on, giving me this opportunity to present this session. In case you joined in late and you didn't know who I was, this is what it is. My name is Nilesh Gule. The combination of my first name and last name is quite unique, and for me it's very easy to find handles on social media sites using this. Except for my blog, you can find me with my first name and last name everywhere else. So thanks once again. I'm happy to take up any questions if you have.
Yeah, thanks a lot, Nilesh.
Dad, come here.
Nilesh, thank you.
That's a lot. That's a lot to absorb.
Yes.
You did a good job of, going through it, and I followed it all. That was good. I did put a link for your GitHub in the comments.
Okay.
And yeah, great. Well, thanks a lot. Yeah, go ahead.
I have two questions. First question is regarding the architecture, where to deploy. Why not deploy virtually on Azure or on AWS from the very beginning? In other words, why would you need hybrid environment where you have VMs and hosts on VMs, and also combined with Azure or AWS environment?
What I'm using in this demo is a managed offering. So although I'm using Azure Kubernetes Service, that is fully managed for me. So you can use the same approach. AWS also has a managed offering for Kubernetes. We are not dealing with VMs directly. We are dealing with the Kubernetes as a whole. So I'm not managing, or I'm not interfacing directly with those VMs. Although I showed that what is the size of the node and all those things, it's mainly a configuration aspect. We can take this onto any cloud provider and it will work. We don't have to work on the infrastructure as a service concept here. This is all like managed offerings that we have.
I understand, but my question is, are there any financial benefits of using combined or hybrid mode where you have 4 VMs and pods on VMs together with virtual node hosted either on Azure or on AWS?
Okay, so are you asking about the auto scaling part where I was showing that we are
Yes.
extending it into the serverless part? Was that your question?
That is correct.
Okay, so the scenario there I would consider is what is your service level objectives? How fast do you want to process that? Let's say you want to manage your Kubernetes cluster and you want to scale that cluster yourself. It would take quite an amount of effort for you to identify when you need to scale. So let's say you have a Black Friday kind of event or you're doing a promotion on Christmas or New Year. You will have to have resources dedicated to manage that scaling part, and you will have to manage it scale up, scale down. Whereas KEDA and the auto scaling using the serverless infrastructure, what it allows us to do is automate this process. I don't really have to keep looking. I don't have to manually manage that part. The benefit I get is on demand. I can scale very quickly. So you saw that within, I think, 2 minutes of time, the scaled containers on the Azure container instances was able to run. Whereas if I have to do it using a physical node cluster, I have to add a node to an existing Kubernetes cluster. It would definitely take more than 10 minutes. You have to first provision the VM. You will have to then install the required services for running Kubernetes onto that. You will also have to add it to the existing cluster. You will have to have the security part. You will have to do the certificates, manage certificates, establish that connectivity. All that will take quite an amount of time. And in a Black Friday or in a scenario where you're running promotions, maybe you don't want to spend that much amount of time. Or you have a very short burstable load. Let's say you don't even know exactly when you are going to get a traffic. You are expecting the traffic to come to your, let's say, a portal or website or whichever process you are using, but it's highly unpredictable. So let's say if end of month process that you're doing, or you have one batch which runs once every quarter, you don't want to run your Kubernetes cluster all throughout that quarter. You just need it for a very short period of time and you want to optimize your cost. At that point of time, you can use this serverless infrastructure only for that short duration. You can have the Kubernetes cluster with a very minimal configuration running for your daily needs, and then you can burst it into this serverless infrastructure when the need arises.
I've got it. Let me rephrase my question. My question is, why would you need mixed environment? Why can't you have everything on Azure container instances, for example, on virtual nodes?
Oh, it depends on how do you want to manage it. When you use Kubernetes, you get many things which are part of the Kubernetes infrastructure. Whereas there are things which are not supported in Azure container instances, like some of the advanced networking scenarios, you cannot handle it using Azure container instances. And Kubernetes has got a lot of ecosystem around it. So from a platform point of view or from an orchestration point of view, if you want to have control over the way your application is orchestrated, you can use Kubernetes. But if you don't need so much of control, if you have very simple application, you can always deploy it using Azure container instances or similar features on other cloud. It's about how much control you want and how much customizations do you need to run your application.
Thank you for clarification. And my second question is regarding the architecture of the application itself. When you have to deal with the autoscaler, why can't you reassign this task by using, for example, Azure Functions or AWS Lambda? So you have, for example, on AWS SQS as a queue management, and then
Yes.
your Lambdas will be autoscaled based on the load. In other
Yes.
words, is this an alternative solution, or there are some bottlenecks that will have some disadvantages?
That's a very good question. I would say that's an alternative solution. So if you're going into AWS Lambda or Azure Functions, the programming model is completely different in those areas, right? But if you're building something like microservices and you have infrastructure which is already built on Kubernetes and you want to scale within Kubernetes itself, then KEDA might be a good option. But if you can scale everything using the serverless components, then I would say the trend now or the way it's picking up now is you could implement it using pure Azure Functions or Lambda. But that would be an alternate approach.
Thank you.
Yep.
Anything else, anybody?
Your own base.
Nilesh, thank you. That was great.
Thank you. I hope it
All
was
right.
useful.
Oh, that was great. Yeah, that's great. I have to re-architect my microservice stuff with Kubernetes now. So.
It was a great presentation.
Yeah, thanks a
Thank
lot.
you. Yeah.
Yeah, and the GitHub will be a good reference.
Yes, I also have a YouTube channel. So some of the things which I could not cover during this session, like the way we interface between the container instances or ACR and the servers. So you can go through my YouTube channel. I have detailed videos which talk about like how do we integrate the private container registry with Azure Kubernetes Service, how do we use container registry with identities in Azure AD and things like that. So this could be another reference for you if you want to learn more.
Excellent.
Yeah.
Okay, well, thanks. I'm going to stop the recording now.
Yep. Thank you.
And,
thanks a
thank
lot
you.
for having me.
Thanks for getting up early and
It's
talking to
9:30
us.
almost for you guys. I
Yeah.
hope I didn't disturb your dinner plans too much.
No, no.
That's
Yeah.
great. Thank you.
All right. Thanks a lot. Appreciate it.
Thank you. Have a nice evening.